Hello everyone, my name is Haikun Huang, and I'm a master student at RWTH-Aachen University. Today I will talk about my master thesis, syntax-oriented semantics analysis for class diagrams. Nowadays, class diagrams is widely used for code generation. There are too many tools that only focus on the syntax analysis, and they can only to find the syntax differences between class diagrams. But our approach is focusing on the semantic analysis, and it can find the semantic differences between class diagrams. Let's get started. What is the semantic differences? Assume we have two class diagrams CD1 and CD2 as the input. Then we use the object diagrams OD as the diff-witness of the semantic differences between CD1 and CD2. And the generated diff-witness is only valid for CD1 but not for CD2. As you can see the example on the right side, we have two class diagrams CD1 and CD2. We can find the right cardinality in the CD1 is star, which is different from the cardinality 0 to 1 in the CD2. Then let's look at the object diagrams OD1 at the bottom. That is an instance Tom for class employee and two instance task1 and task2 for class task. In addition, Tom has two links to task1 and task2. In the result, you can see the current OD is only valid for CD1, not for CD2. Currently, we have an approach alloy-based semantic diff in CDDiff tool that can find the semantic difference between CDs. It uses the model check alloy to calculating the result in first-order logic. The workflow of alloy-based semantic diff is that use the two class diagrams CD1 and CD2 as inputs. Then they will be mapping into the alloy modules. Next, it will use the module checker alloy to calculating the instance if there exists an instance in result. Then the instance will be transformed into ODs as diff-witness. But there are several problems in this method. First, it used the model checker alloy to calculating the instance, so the calculating process is exhaustive search and that is not efficient. Second, it should determine a small scope value k to fix the number of instances. Third, it cannot determine the location of syntax differences. That means we don't know which syntax differences in CDs causing the current semantic differences. At last, sometimes there are some redundant diff-witnesses in the result. To address the above problems, we must find a way to find the semantic differences without using the model check alloy, and it can also detect the syntax differences and record its location. In addition, it can generate the minimal diff-witness for semantic diff. The name of the new approach is syntax to semantic diff, and the main concept for it is using syntax diff analysis as base for semantic diff. As you can see, the graph is about the workflow of syntax to semantic diff. First, we use two class diagrams, CD1 and CD2, as inputs. Then we determine the syntax differences between the two class diagrams using syntax diff analysis. Next, we separate the syntax diff between type and association into type diff and association diff. For type diff, we need to consider the syntax differences of the attributes and so on. For the association diff, for example, we need to consider the syntax differences of the cardinality and the navigation. Then we will take the semantic analysis process on each syntax diff. In this step, the semantic options that is single or multi-instance in closed word will be considered. After the semantic analysis, we will generate the diff-witness ODs if there exists a semantic diff between CDs. For example, we have two CDs, CD1 and CD2, and you can find there are many syntactic differences between these two CDs, such as the attribute electricity has been deleted from CD2. The class lessons has also been deleted from CD2. The navigation is refined from undirected to one-directed in CD2. The multiplicity is also has been changed from star to 0 to 1, and the attribute ID has been added into class driver in CD2. In the next step, I will show the main concept for find semantic differences based on these syntactic differences. First, the type diff and association diff will pass through the filter to reduce the redundant case. Next, we will create an initial object structure for type diff and association diff based on the syntactic differences information. In this step, the initial object structure for type diff can be transformed into the object structure for association diff. Then we will use the class stack and association stack to repeatedly switch from target mode and source mode to complete the object structure until the class stack and association stack is empty and no new instance will be added into the object structure. We will get the final completed object structure. Then we will fill out the invalid case and add the location information of syntactic differences into ODs. Finally, we get the diff-witness. This is the example, same as before, but now we only focus on the cardinality change that has been changed from star to 0 to 1. Firstly, we should calculating the complement set for these cardinalities, and the result is 2 more. Based on the calculating complement set for these cardinalities and using the class stack and association stack, we get the final completed object diagrams on the left side. And on the right side, there is the related textual object diagrams in UMLP. You can see we added label positive CD and negative CD to show the location of the syntax differences, and label syntax diff category to show which kind of syntax differences causes this current semantic diff. And for each syntax diff in CDs, we will generate one related diff-witness. This is the example of single instance in the closed world case. And this is the example of multi-instance in closed world case. On the left side, there are two original CDs, and on the right side, there is the related textual object diagrams in UMLP as diff-witness. In addition, you can see we add a label instance of to show the superclasses of the current instance. In positive CD on the line number 7, we can find that class car extends vehicle, and in the negative CD on the line number 4, we can find that class car has no superclasses. But in the OD, the class car is instance of vehicle and car. So this generated OD is only valid for positive CD, not for the negative CD. In conclusion, syntax to semantic diff has some advantage over LY-based semantic diff. First, syntax to semantic diff avoids exhausting searching without using the model check LY. Then it is faster and more efficient than LY-based semantic diff. We can see the graph on the right side. It shows when the scalar of CDs becomes larger, the running time of syntax to semantic diff grows slower than the LY-based semantic diff. Third, syntax to semantic diff can detect which syntax differences causing semantic differences and mark its location in OD. Then it can also create the minimal witness, and there is no redundant diff-witness in result. Finally, it can handle single and multi-instance in closed world cases.